and then try to pull points from the word problem. So if I read this again, they say write an equation to model the depth of the water, y. So what should I label based on that piece of information? What's that? The water depth, and what gets labeled water depth? The what? The y-axis, right. Y-axis, depth of water. Now, as far as scaling that axis, take a look at the depths that we were given. 6 feet was our lowest, and 12 feet was our highest. Can we count by ones? Because clearly this is a bold-faced 0. So 1, 2, 3, 4, 5, 6 is our lowest. 7, 8, 9, 10, 11, 12. Counting by ones was fine. It fits, go with it. Then, based on the number of hours after midnight, is our x. So number of hours after midnight. So if this is 1, what does that mean? 1 hour after midnight means 1 a.m., right? 2, 3, 4, 5 a.m., 6, 7, 8, 9, 10 a.m., 11, 12 is noon. You want to write noon, you can. 1. So even though this is going to be 13, we know that 13 hours after midnight is technically 1 p.m., right? 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this would be midnight the next day. Yes? So they define for us number of hours after midnight. So if low tide occurs at 6 a.m., so 6 a.m. is right here, and what was the depth at low tide? Read. 6 feet. 6 a.m., 6 feet. Put a point there. And that's the lowest the depth of water is ever going to get. High tide was at noon. So we're at our 12 hours after midnight, and that was at 12 feet. So that's our low to our high. So knowing that this is a cyclical graph, we're not going to connect those with a straight line, right? You've got to get used to the curvature here. So where's the midline, can I ask? If low is at 6 and high is at 12, minimum at 6, maximum at 12, where's the midline? 9. So I would get that on your paper to help you with your symmetry. So given that we have those 4 equally spaced stretches of every cycle, when is this going to cross the midline? If it's minimum at 6 and maximum at 12, where is it going to cross the midline? At what hour? Because our first stretch is going to bring us to the midline, and our next stretch is going to bring us after. Kaylee? I'm talking when I connect these two. 9. 9 again, right? So I'm going to put, remember there's 5 critical points. So I'm going to do this and that. And then it's all evenly spaced. So obviously we've just kind of highlighted that our critical points are happening every 3 hours. Starting at the minimum, 3 hours till we get to the midline, 3 more hours till we get to the maximum. 3 more hours, so we're at noon. So at 3 p.m. we'll get back to the midline, and 3 more hours we'll get to the minimum. Now, this certainly looks like what kind of curve? Negative cosine. And I can treat this as a negative cosine if I want to, but I will have a phase shift because this is not at all starting on the y-axis, is it? Okay, so I could treat it as a negative cosine, but there would be a phase shift of how many units to the right? 6. So if I do it that way, it's a negative cosine I have to find B still, but I do know that there's a 6-unit shift to the right. What's my midline? Plus 9. So I can put the plus 9 in for the D. What is my period? If this cycle starts at 6 a.m. and it ends at 18 hours, 12. So 12 equals 2 pi over B. Cross multiply to solve for that real quick. B is pi over 6. And what's my amplitude? Three. Good. So this is one option. It says write an equation. It doesn't say write the equation because there's not one and only one. Write an equation. So if we didn't want to do that, and some people want to avoid phase shifts, then that's fine. We could kind of continue this cycle backwards. Remember, every 3 hours we have a critical point. So this is going to now come back up to the midline 3 hours over, which would be there. What if you started your cycle there? What would you be writing? A negative sign, right? With a phase shift 3 units to the right. Yes? Okay? Or then if we really don't want a phase shift, which I get it, you would go 3 units back to your next critical point, which would be a maximum. And there you'd be writing a positive cosine. This would probably be, I don't know if it's easier or not, but this one has no phase shift. What's harder about this way is that we actually had to bring the graph backwards. So there's pluses and minuses to both options. Okay? So we could write a positive cosine with no phase shift. The amplitude would still be 3. The midline would be 9. So remember, those things are not affected. Okay? Any questions on that? All right, so on our notes, I want you to wait, that's day 2 of modeling. Okay. On this one, again with the tides, it's telling us D equals, and they've labeled the y-axis D already for you, so that's done. And it's in terms of T, not X. So they've labeled the x-axis T for you and told you hours. So they've kind of done a little legwork there. T represents the number of hours since high tide. So this must be high tide. Right? Yeah. And D represents the depth of the water in the bay. So this is depth. The maximum depth is 36 feet. That would be at high tide or low tide? High tide, 36 feet. So let's start it at 36. And we're starting at high tide, they said. The minimum depth is 22, so I'll just throw 22 on there. I don't have grid lines, so I don't need to be perfect about that. But the question is, when does it reach low tide, right? So it's at high tide. It's going to get down to low tide before it comes back up. Do you follow? The question is, when is it reaching that low tide? Does it say? Let me think. The maximum depth is 36, the minimum depth is 22, and high tide is hit every 12 hours. So if high tide is hit every 12 hours, what would that be, Connor? 6. Very good. High tide to high tide is 12 hours. So halfway between there would be 6. And again, this is a cycle that's happening every 3 hours. So get your midline in there. Where's our midline? Average the 36 and the 22. So add them up and divide by 2. So 36 plus 22 is 46, 50, 58. And then divide by 2, 29. 29. So your midline's at 29, and we're hitting the midline at that critical point, which is at the 3-hour mark, and we're hitting the midline here, halfway between 6 and 12, at the 9-hour mark. See your 5 critical points, which creates 4 intervals. Interval 1 every 3 hours, interval 2, interval 3, interval 4. So, what is my amplitude, Maggie? Seven. Your midline's at 29, and we go up to 36. That's 7. Period. What is the period, do you think? Maddie. 12. It's the length of our cycle, 12 hours. We haven't talked about this yet. We've talked about B, obviously. B is your frequency. It's your number of cycles that occur in a given amount of time. There's more to come on that, so just focus on your B right now. But if you ever see frequency, frequency is just B. We'll talk more about it. It's come up lightly so far. So we have to calculate our B, don't we? So period equals 2 pi over B. We now know the period is 12, so 12 equals 2 pi over B. Cross multiply, you get 12B equals 2 pi. Divide by 12, and B equals pi over 6. And the midline we've already decided is 29. So we're going to write an equation. And by the way, sometimes they'll dictate for you. They're telling you you have to write a cosine curve with no phase shift. So they've written their structure without the t minus c part because they're telling you, I don't want you to do a phase shift. They're telling you you have to use this format. So in the way they've written theirs, their midline is in the C spot versus when I do it with all of these transformations, mine is plus D. Do you follow? That's because they're taking the phase shift out of this. So just be wary that really C and D can be different, but know that this plus whatever at the very end is your midline. So to write this equation, it's D equals your A, it's a positive cosine, correct? So your A is just that positive 7. Our cosine of BT, which is pi over 6T, plus our C is plus our midline of 29. Okay? Any questions? And why don't you just put your pencils down and take this in, because I want to finish it and I don't want to wait for you to write. You could always go back and watch this one. This, I believe, was on a Regents. I'm trying to think where I stole this from. Tanker boats cannot be in the bay when the depth of water is less than or equal to 25 feet. Okay? So it wouldn't be deep enough for that big of a boat. Set up an inequality and solve it graphically to determine all the points in time t, where t is between 0 and 24 hours, when tankers cannot be in the bay. So round all times to the nearest tenth of an hour. Oh, so this is piggybacking on this question. Maybe you can write it down. I thought it was going to be a whole new question. So we need our depth. We're setting up an inequality and solving it graphically to determine all the points when tankers cannot be. So the tankers cannot be in the bay if this depth is ever less than or equal to 25. So here's your depth. Whenever this is less than or equal to 25, whenever that depth is less than or equal to 25, the tankers can't be in the bay. So there's the setup of the inequality. We're never going to solve these algebraically by hand. That's why they say solve it graphically. So if I go back up to the graph, 25 is about here, right? So anywhere from this hour, whatever that might be, all along here until this hour, whatever that might be, this section, the tanker cannot be in the bay. So they ask you to solve it graphically, and that means on your calculator, to figure out what hour is that and what hour is that, so that the tanker knows not to go in the bay between those hours. Yes? So if I type this onto my calculator, the function I wrote, which is 7 cosine, what mode do I have to be in? Good. Wait, what'd you say? Radians. Oh, I thought someone said degrees. Okay, so, and what's an appropriate window? 0 to 12 hours? Is that good enough? 0 to 12. What's an appropriate Y window? 0 to 36. Let's go 0 to 40 just to make sure we cover it all. And so here's our trig graph, but we also want to graph that 25-foot line, that horizontal line that's going across, right? Because we're going to be looking for the points of intersection to figure out the hours. So I'm going to go back and I'm also going to graph y equals 25 because that's a depth of 25. And I'm looking for this point of intersection so I know what hour that's occurring at and this point of intersection. So second trace, intersect, and scroll over to this point of intersection. Pretty much you just hit enter 3 times. 1, 2, 3. That's happening at the hour 4.16. Does it say to the nearest tenth? Okay, so 4.2. All the way until over here, so second trace and find the other intersection point. Tanker can't be in, tanker can't be in, tanker can't be in. And then over here, enter, enter, enter. That's at 7.8 hours. Between 4.2 hours and 7.8 hours, the tanker boats cannot be in the bay. Does that make sense? And that's what we've seen with these Regents questions. We've seen like an application. So do the skill, and now can you, and that's what the Common Core is all about. Can you apply this to something that really happens somewhere in the real world? Will you ever be doing that job? Probably not. But somebody is. Scientists are. And they need to understand the math behind this to predict when these ships can enter the ports and so forth. So your homework is real short. But it's just these, but it's a lengthy, thought-provoking question. So just the 2 questions on the back is your homework. Okay?